Okay, back again. Today we're going to be looking at starting a little bit on polynomials here, and we're going to look at defining polynomials and what we talk about when we mean degree. So, if we look at a polynomial, a polynomial really, if we want to define this, we're going to say a polynomial in X, because this is a variable we normally talk about. Basically, it's a finite, so it does have an end. It's a finite sum of terms in the form of, let's see, how do I want to put this? Ax to the n. Okay. Now, there, a has to be a real number. Okay, so we have a is a real number, and n has to be a whole number. Okay, so a polynomial, if we want to define that, if we're doing it in x, just because x is the most common variable, it's a finite sum of terms in the form of a times x to the n. So we could look at something here like x to the fifth minus 2x cubed plus x minus 4. Okay, this is a polynomial. Oops. And we use polynomial as a general term. And when we look at these, when we look at polynomials, they're made up of, we set a finite sum of terms. There's a term, there's a term, there's a term, there's a term. So I have 4 terms here. Now we can look at polynomials as being monomials, which means we have 1 term. We can look at a binomial, where we have 2 terms. Or we can look at a trinomial, where we have 3 terms. Okay. Now, that's not to say there aren't any other terms, but a polynomial, by and large, is any of these monomial, binomial, trinomial, quadnomials. We would have 4 terms. We can have 5, 6, 7, 8. We can have essentially limitless amount of terms, although it's to say a finite sum of terms, meaning when we add them together, we reach an endpoint. So, one thing we need to pay attention to as we look at this, look at our x's with our powers here. We go from 5 to 3 to 1. Okay? Polynomials, we usually like to see those written in descending powers of x. Okay? Now, if we have something like x to the negative fifth, this is not a polynomial because it has a negative sign in front of the exponent. Okay? Now, I keep talking about the exponents here, and this is important because we need to talk about degrees. And if we talk about the degree of a term, okay, and remember, a term is, all these are terms. So it's the sum of the exponents, on the variables, in the term. Okay? So the degree of a term is the sum of the exponents and variables in the term. So if we want to say, okay, for example, we have a monomial here, 4x to the fifth. What is the degree of this? Well, the degree of this term is 5, because that's the exponent we have in the variables there. Here's one. What if we have 2 cubed x to the third? Well, the degree on this is 3, because we only use exponents that are on variables. Okay? Now, that being said, now we know what a degree of a term is. What about the degree of a polynomial. We have to know that. And we talk about the degree of a polynomial. It's the greatest degree of any term that's contained in the polynomial. So any term in the polynomial. Okay. So if we had a polynomial, for example, 3x to the fourth minus 2x cubed plus x squared minus 3x, and we'll put plus 1 at the end. Okay. If we have something like this, and we say, what's the degree of this whole polynomial? What's the degree? Well, the degree would be 4. So it's the greatest degree. The terms we have, we don't have a term here. Well, we have a term, but we don't have a degree to 1 because 1 is a constant or a number. 3x, we have a degree of 1, x squared is a degree of 2, x cubed is a degree of 3, 3x to the fourth is a degree of 4. And for a polynomial, the degree of the polynomial is the greatest degree of any term in the polynomial. So, hopefully, this gives you a little introduction to polynomials and what we talk about when we mean degrees of terms and degrees of polynomials. We'll start looking at polynomial functions and such here soon, so have a good day. Bye.